In this video, we're going to go over how to solve two-step equations. So first, let's look at what a two-step equation actually is. So here is an example of a two-step equation. 2x plus 5 equals 15. It's called a two-step equation because there are two operations being done to the variable. The variable, of course, is x and represents an unknown number. Here, the variable is being multiplied by 2, and then 5 is being added to it, and that gives us the result of 15. A lot of teachers will tell you to solve this by just moving the numbers to the other side, but that doesn't really explain what's happening. So instead, we're going to think of this equation as a balance scale. So on the left side, we have 2x plus 15. And on the right, we have 15. So we want both of these values to be the same. An equation is like a balance. Whatever is on the left has to equal whatever is on the right. That's what this equal sign represents. And the key rule here is whatever you do to one side, you must do to the other side, because if you don't, it is no longer equal. Think of this as adding or removing a weight from a scale. So let me just draw a scale over here with 3 on each side, 3 balls on each side. And now let's add a 1 to our left side. This will cause the scale to tip over this side as it's going to be heavier. To keep that from happening, we have to do the same thing to the right side. So we can just add one more ball here, and then this will be equal, and this side will not tip over anymore. The same logic applies to solving two-step equations. We want to remove a certain value from here to get x, and we have to also remove the same thing from our right side. Now let's try solving the equation now that we know what to do. So we have 2x plus 5 equals 15. Whenever we solve equations, we have to follow reverse PEMDAS. So let me just write that over here on our left. I'll just erase this now, and then, so P we have for parentheses, E for exponents, M for multiplication, D for division, and then we have A for addition, S for subtraction. So we want to follow reverse order when solving our equations. Now let's try solving this equation with that in mind. Firstly, we will have to undo our addition. We can do that by doing the opposite operation, which is subtraction. So we will subtract 5 on both sides. We have 5 here, and then we're taking 5 away, so we can cancel that out. And that gives us just 2x on the left. And 15 minus 5 just gives us 10. Notice, the 5 didn't randomly move here. We subtracted 5 from both sides to keep the balance fair. Now the equation is simpler, but we're not done yet. Next, the variable is being multiplied by 2. To undo multiplication, we divide. So we will divide by 2 on the left and divide by 2 on the right. So 2 divided by 2 gives us 1. This will be 1x equals 10 divided by 2 is 5. And 1x equals 5 is the same thing as saying x equals 5. So this is our answer. We can check that this is right by plugging this back to our original equation. So we have 2 times 5 plus 5, and that should give us 15. So I'll write it like this. So we have 10 plus 5, and then we get 15. And since 15 equals 15, we are correct. Let's try another example. 3x minus 4 equals 11. First, we undo subtraction, so that'll be plus 4 on both sides, and this will cancel out to give us 3x, and this side will give us 15. Next, we undo multiplication by dividing. So dividing by 3 here and dividing by 3 here. And this gives us 1x, and this will be 5. So we have 1x equals 5, which is the same thing as saying 1 equals 5. And let's check that this is true by doing the same thing. So we have 3 times 5 minus 4 should give us 11. So this will be 15 minus 4, which is 11. Since 11 equals 11, we are correct. Here are the two general rules for all two-step equations. So firstly, we will do the operation to both sides of the equation to ensure that we have a balance in our question. Next, we will follow reverse PEMDAS. So that'll be addition and subtraction first, and then division, multiplication. And then if we have exponents, we will do that, and then parentheses. Once you understand these two rules, two-step equations become very easy to solve. Here's a challenge problem if you found these last two very easy to solve.